All right, hi everyone. Today we're going to go through integration, definite integrals now. So we're going to have to be substituting some values in, but there's a couple things that we need to pay attention to because there's actually two ways to do definite integration, definite integrals. Okay, so Arcuda software is going to go through one way, but I want you guys to make sure you know both ways because I feel one way is more natural to me, but you need to know both ways. Okay, so let's go ahead and solve with a fairly easy problem. Let's do the integral from 0 to 2 of x squared over, let's do 2x squared. Let's just do 3x squared, sorry, 3x squared, sorry, dx. Okay, this is my problem to start. Okay, so this seems like a pretty easy power rule problem. There's no u substitution here. So when I normally take an integral with a definite integral, we go ahead and just take our integral. We say the integral of 3x squared is 3x cubed over 3, right? Power rule, nicely simpled out. And then we always plug in the top minus the bottom. So it's f of b minus f of a. That's the idea of f of b minus f of a, where we're taking our integral and we're going to plug in the top value, which is 2 cubed minus 0 cubed. Okay. And this becomes 8 minus 0 is 8. Okay, that's the basic idea of a definite integral. So we know this already. Okay, so what if I jump to a slightly more difficult problem and I say this instead? Let's pick a number. Let's do the integral of 8x over 4x squared plus 1 squared. Okay, this problem looks a little crazy to start. But can you think about, could I use u substitution on this? Yeah, right? U substitution. In your head, take the derivative of 4x squared plus 1. That's going to give us 8x, and that nicely gets rid of the 8x on top. I forgot to write dx here, I'm sorry. So we know this is a u substitution problem already. So let's just do it. Now, I'm going to make this a definite integral problem now. I'm going to call this from -1 to 0. Now, this is a definite integral. That means I don't write plus c. We're going to end up plugging values in afterwards. But there's a couple of aspects that we need to be careful of. First thing is, let's go ahead and call u. U is equal to 4x squared plus 1. Du is 8x, okay, dx. And then dx is equal to du over 8x. That's always like autofill. Once you write u, you take the derivative and then you solve for dx automatically. When I replug this back in, there's a problem with this universe. So let's go ahead and rewrite it. It's going to be 8x over u squared. And we switch du over 8x, right? And 8x divides out. And we have a problem coming up. I'm going to go ahead and finish this, the easy parts, where you have du over u squared. Okay. Now, if you notice, I forgot to write something. I forgot to write -1 and 0, right? -1 and 0. But there is a problem here. The problem is that this variable here, right? If I look back at my previous example, this was an x value because I'm going to plug it back in later as an x value. Okay? These are x values. These are x values. These are x values. But what values do we have left? We don't have any x values. We swapped them all with u values, didn't we? And that's the dilemma. You went to China, you speak English, you need a translator, right? We're in China now, we're in U country, okay? So here's what you have to do. So what happens is this is actually the wrong values we use. So what we do is we cheat, not really cheat, but we rewrite it. We go ahead and we say, hey, x was 0. Well, if x is 0, what is it in U universe? So u, so if I say x is 0, we're going to say, hey, what is the u version of this? What's the u version of this? Well, that's 0 plus 1. The u version is just 1. Okay? So I'm going to cross this out. you are now really a 1 in the u universe. How about the other guy? When x was -1, what was it in the u universe? This was 4 -1 squared plus 1. That becomes a positive 1, so it'll be 4 plus 1 is 5. So u is equal to 5, right? So what happens in the u universe? This is now 5. So the way what you're supposed to do officially is you're supposed to write it this way. You're supposed to say, you know what? From here to here, we have the integral of 1 to 5 of du over u squared. Okay, so this is officially what you're supposed to do, because we are not dealing with x's anymore. 0 and -1 were an x term, right? We're speaking English here. But once you switch over to another country, another universe, we have to switch our x values to also match that universe, that u value problem. Okay. Now we can go ahead and take the integral. Integral of from 1 to 5 is, this is just FYI, remember this is u to the -2 power. So if we do power rule, that's u to the -1 over -1. Oh, sorry, whoops, my bad. I took the integral, my bad. The integral of that, I'm so sorry. We were taking the integral already. And we're going to plug in 1 and 5. Now, normally, at this point, we would change our u back to our x version, right? That's normally what we did before. We changed the u back to x after we took the integral. But because it's a definite integral, we can now plug in the values. And we read this as 1 over u, right? That's what this is, 1 and 5. Since these are u values, right? These are u values, we can just plug them in. It's -1 over 4 minus -1 over 5. Oh, that's another 4. That's a 1. That's a 1. That's a 1. That's a 1. I don't know. I read my u as a 1 over 1 minus 1 over 5. Okay, these values are these values here.
Mr. Cole, I have a question.
Yes.
How'd you get from du divided by u squared to the rest of what you got?
Okay, so I took the integral. So this here is integral of 1 over u squared du. And the power rule is integral of u squared, negative u squared, u to the -2 power du plus 1 over n plus 1. That's why it's u to the -1 over -1. That's how I ended up with that guy here. I went ahead and took the integral of that. And after you take the integral, you can normally plug in those a and b values. And our answer, just to finish off our answer here, our answer is going to be -1 plus 1 over 5, which is -4 over 5, I think.
You just flip u -1 divided by -1, and then.
Yeah, so this is negative exponents belong on top or on bottom. They belong on the bottom.
Top. Oh, yeah.
Yeah, if negative on top means it's on the bottom. Negative on the bottom means you become on the top. You're not from around here. Get over to your side. I'm over here now. And the -1 I moved to the front.
Why didn't we substitute the u back in?
So why didn't we? So in the definite integral, so here's the thing. This is the part I said there's two ways of doing it. One way, which you need to know, because oftentimes they might write it in the test like this, is that they leave it in u. They leave it in this u substitution form, and you have to make sure you write it in the u version. Okay? So if we do it this way, we leave everyone as u. We're stuck in China. We're speaking Chinese now. Ni hao ma, okay?
Mm-hmm.
But we can always switch this back to English. Now, here is the second way of doing this. All right? I'm going to take it off from right here. So here is our second version, which is what I find more intuitive. I find this way more intuitive. The second version is, you know what? From this point, integral of 1 over, what did I say? 1 over u squared? Yeah, 1 over u squared du. Okay, from this point here, what if I don't want to plug in u? Fine, don't. It's still going to be 0 and -1. But make sure you realize that these are not the correct values. We're not going to plug it in. We're going to hold off on it. And this is what I'm going to do. I'm going to say, you know what? Let's just take the integral like we did before. This will equal to, remember, this is u to the -2 power. So using power rule, u to the negative 1 over negative 1, negative 1, 0. So if you notice here, I'm still keeping these as x. That's an x value. That's an x value, okay? At this point, let's go ahead and substitute u back in. We said u was some crazy value up here. We said u was, what was u? 8x or something? Where's the summer?
Squared plus 1.
Okay, thank you. 4x squared plus 1. So u equals to 4x squared plus 1. We can plug it back in. So we end up with negative 1 over 4x squared plus 1. I'm rewriting it. I'm rewriting the u on the bottom. 1 over u. And then plugging back my u. So here's the other version. You don't change your x values to u. You know what? You're going to hold off to the very end. You just know what? I'm going to change back my language back to x's. I changed it back to x's here, as you guys can all see. Now here's the cool part. Because if I do plug in 0, negative 1 over 4 squared, which is 0 plus 1. I'll make it look a little prettier for you guys. Negative 1 over 4 times 0 plus 1 minus negative 1 over 4 negative 1 squared plus 1. We end up with negative 1 over 1 minus negative 1 over 4 plus 1 is 5. I want you to stop here and I want you guys to see that they're actually the same thing. What I wrote here and what I wrote here are exactly the same thing.
Why does the
Why is
second?
it negative?
Go ahead.
No, you can go ahead. It's fine.
I was just gonna say, why does this one seem so much easier?
It's because we've been doing it this way since we learned u substitution. We always switched it back. Okay? But what happens is we could have left it as u the whole time. We could have just lived in the world of u's and stayed as a u problem. We didn't have to come back to x.
It seems like it takes more time to do the first version, though.
It might seem like it because do you see how you actually wrote out the math right here?
Mm-hmm.
I'm going to tell you this. If you count step per step,
Oh, you usually do it mentally?
yeah, a step per step, you're going to actually do the same amount of steps in your head. There actually is no gain or loss, whichever method you use, just whichever one you're more comfortable with. You could have left it as u and stayed in u form up here. Or you could always switch back to x and then plug in this negative 1, negative 0, and negative 1 where we started from. And that's my point about this in this definite integral, is that if we stay in u, and actually sometimes on the AP exam they leave it in u form, so you have to stay in u mode. But you don't have to. If this is you, yourself, and I, right? You can always come back to x, and I normally come back to x. But on the CUDA software, the first column, I purposely left it in u form. So when you guys set it up, you're going to be asked to rewrite this problem in u form, and you're going to just write this answer here. Okay. So the first part of CUDA is just you setting up the indefinite integral with the u from a to b. It's our new version in u. Okay, just to make sure you guys know how to do that, because they will ask you this sometimes on the AP exam, and they'll trick you. They will write the u version as this version, which is not right, because 0 and negative 1, right? The 0 and negative 1 are x values, not u values, and that's how they're going to screw you over. Okay. If you want to write 0 and negative 1, that's fine, but remember, these are just like temporal, like blips. We're going to come back later and plug them in as regular values over here, right? We're just keeping them in pause, so we don't have to do any extra work. But again, you would be doing the work anyways. Now, what I mean by you would be doing the work anyways, when I was doing u up here, remember how we plugged in 4 times 0 squared plus 1? Okay, 4 times 0 squared plus 1. We actually do that right here. We were going to do the work anyways. Up here, for the second u value, we plugged in the negative 1. 4 negative 1 squared plus 1, we got 5. We actually did that work anyways right here. See, we did that work anyways. So it's not like you do save time anywhere along the way. It's just that you have to pick a path and stick to it. If you go from x's to u's, you might as well stay in u's. But if you go from x to u's and you want to come back to x's, you want to make sure you stick to that path. Okay. So let's look at another problem to show you that these aren't quite super terrible, but we have to make sure we know how to set it up. Okay, let's do another problem. A lot of the problems that you guys are seeing are going to be these power rule problems for homework. So it's just to make sure you guys get the idea. So the integral, no, this is not 7. Let's do a, okay, let's do this one. Let's do number 12. 12, okay. So it goes the integral from -5 to -4 to -5, sorry, -4 to -5 of -4 over 2x plus 4 dx. So my question to you here, do I need a u substitution for this problem?
Not really.
Like, how else would you solve it? And this is one of the ones that are tricky, and this is for sure the u substitution problem. It just doesn't seem like one. And the reason why is we're used to stuff like this. We'll see x squared plus 2x over x, and we're saying, hey, I could simplify that first, so it's no longer a fraction problem. But in this, because of the plus 4 here, it's actually a u substitution problem. It's just not obviously one. And again, sometimes the simple ones are the ones that are the trickiest. So if I say u is equal to 2x plus 4, take the derivative, that's going to be du is equal to 2 dx. dx is equal to du over 2. Okay. And you'll realize that this is actually a u problem. -4 over u, 1 over u, and we're going to say du over 2. Those simplify out, and we're left with a nice integral of -2 over u du. And hopefully you see this is actually a natural log problem. And this is the ones that usually I'm like, oh crap. When I wasn't doing these day by day, I kept forgetting that this was actually a u substitution problem, which made the problem super easy because this is just a natural log problem. Now, because we were able to simplify it, now we can say this is really, I'm going to rewrite this, you don't have to write it, but it's really -2 1 over u du, which is straight definition. Now here is the fishy part. The fishy part is, do I keep it as -4, -5, -4, -5, -4, -5? Do I keep it that way? And sure, you can. But the idea is that once we switch over, let's go ahead and we'll go right at the integral, -2 natural log of u, and we're going to plug in -4, -5. We have to make sure we switch back to x. -2 natural log of, we said our x was 2x plus 4. 2x plus 4. Plugging in -4, -5. Do I have to write plus c here? No, because it's a definite integral. I gave you our boundaries, our a and our b value. Okay. So if I plug this in, it's going to be -2 natural log of 2 times -4 plus 4, close it, minus parentheses -2 natural log absolute value 2 times -4, no sorry, not -4, -5, I'm sorry, -5 plus 4, close it. Okay.
I thought it was top minus bottom.
It is top
Oh,
minus bottom.
I wrote it backwards, my bad.
It is. It's always going to be top minus bottom. So here's the part I want you guys to notice right here. This inside part, that's going to be -8 plus 4 is -4. Then -2 natural log of -4 minus 2. I'm going to write plus 2 right now. Natural log, and the inside is going to be 10 minus 4 is -6. Okay, so I'm going to leave it there. The negatives go away. Okay, sure, whatever. I'm just going to leave it there for now. The reason why I want to leave it here for now, I want to actually go back and we're going to take our second form. We're going to go ahead from here and rewrite it. So we're going to switch our u's. So we said u is equal to 2x plus 4. I'm going to plug in the -4 and the -5 and get my new versions of it. If I plug in negative 4, 2 times negative 4 plus 4 is negative 4. And 2 times negative 5 is 10 plus 4 is negative 6. All right, we have those values. We rewrite it as the integral from negative 4 to negative 6.
But where is that from, that u is equal to 2x plus 4?
That's the original u that we chose up here, the original u substitution.
Oh, yeah, okay.
We go back to the u that we called it. We're not changing our u value, we're just...
Yeah, the original.
Yep. So at this point, I've actually corrected myself. And I said, know what? These are true u's. These are true believers here. Okay, true believers now. All right, so now when I do my integration, which is exactly the same steps, right? Those are exactly the same steps. We end up with negative 2 natural log of absolute value of u, and we're going to plug in negative 4 and negative 6. Now, if you look here, so this is I'm going to plug in the negative 4 and negative 6, right? And it's going to look just like this right here. So either you do the work beforehand or you do the work afterwards. It doesn't matter. You're still going to do the work in the end. In this case, I did not change myself back to X. I apparently stayed in China. And I speak fluent Chinese now. And we can simplify this to be negative 2 natural log of 4 plus 2 natural log of 6. Same thing here, negative 2 natural log of 4 plus 2 natural log of 6. So you always end up with the same answer. It just depends which one you're more comfortable with. Do you want to change ahead of time to get ahead of the change, or want to change afterwards? But there is no difference. The only thing that you can argue is that, you know what? If I change later on, you have to write again a lot. But my point also is to argue that you wrote this here anyways, right? You wrote that anyways. So, did you really write that much more? Maybe this one step here, you wrote a little bit more. But besides that, you were going to do exactly the same thing on both. Okay, so that's the main thing about these definite integrals, is that we have to plug in our a and b values, and it's again up to you. Do you want to change those a and b's to u's right away, or you want to wait to change them back to x's later on? Okay, let's give ourselves, let's look at one more problem here. Oh no, I didn't put those in multiple choice. Shoot, might have to upload this homework again. No, never mind. Okay, here's our 11. Okay, integral from 0 to, sorry, let's do another one. Let's do from 1 to negative 1 of 3e to the 2x minus 2 dx, okay? So this one looks a little trippy. I know what e to the x is. I don't know what e to the 2x minus 2 is. I don't know what that is. So we're going to call it u is to be 2x minus 2, because if I take the derivative of 2x minus 2, this x really doesn't matter. So it's dx, it's du over 2. Okay. Let's go ahead and rewrite this. It's going to be integral of 1 and negative 1 of 3e to the u du over 2. So I've kept this as x's, right? Just be aware these are still x's. I haven't gone over to the dark side. And I'm going to rewrite this as 3 over 2, because the 3 and the 2 are constants. Integral from negative 1 to 1 of e to the u du. Now, you could, of course, flipped it around, and you could have said instead, let's go ahead and plug in negative 1. If u is equal to 2x minus 2, well, then my new values are going to be 2 times 1 minus 2. That gives me 0. And 2 negative 1 minus 2 is negative 4. And you could rewrote this as the integral of 3 over 2 of 0 to negative 4 of e to the u du. Okay, so either of these paths you could have taken, pick one. Okay, either you're going to change your u's now, or you don't change your u's at all. sorry, x's, change your x's. Okay, so these are in u form, and these are still in x. So be aware of which path you took. The high road and the low road still leads to the same place. But you can see I actually did all the work right here, so I'm not going to have to do the work later. All right, so let's go ahead and finish. Let's do the u one first. 3 over 2. And it's going to be e to the u, because the derivative of e to the u is e to the u. And we're going to plug in 0, negative 4. So we end up with 3 over 2. Let's use the parentheses over them all. So e to the 0 minus e to the negative 4. Let's see what happens if we took the long, not really long route. But that's right, 3 over 2. And this is going to be e to the u. Plug in negative 1 and, sorry, 1 to negative 1. No, negative 1 to 1. Right, you always read this way. We always read up negative 1 to 1. And then I'm going to change it 3 over 2 e to the 2x minus 2, negative 1 to 1. If I plug it back in, I'm going to write 3 over 2. I'm going to keep this out in the front because we're going to multiply 3 by 2 anyways. So e to the 2 times 1 minus 2 minus e to the 2 times negative 1 minus 2. Right? And if you do the math, this would still become e to the 0 minus e to the negative 4. Same thing. Right? But please be aware, you have to know both ways. You have to know both ways. Essentially, they're the same. Whether you're going to plug in u now or u later, you're going to plug in x to the problem. That's over 2. Okay. Just FYI, to simplify this, this does look a little funny. It's a 1 minus e to the negative 4. And sometimes they just want to write this as a common denominator. So it's e minus 1 over e to the 4th. And then I've seen things written as, hey, this needs a common denominator. So this is e to the 4th minus 1 all over e to the 4th. And then times 3 over 2. So if you want to distribute, it's 3 e to the 4th minus 3 over 2 e to the 4th. Just to play that out in case you've seen this before. All right, that's it. That's the only difference. So how is definite integrals different than indefinite? First thing, you don't have to write c. I didn't write plus c anywhere. We didn't write any of this stuff. Second is you have two paths to get there because you're going to have to plug in your a and b. Yeah, plug them in eventually. You can plug them in with the u sub, or you can plug them in at the very end with this u sub. Okay. And in the end, since it's a definite integral, you will end up with one solid answer. And this is actually some decimal number. This is like 1.473. I don't know that. I just looked on a sheet. Okay, that's it.